Okay, guys, let's solve the second and final question we're given as a take home in our previous lesson on the law of conservation of matter of mass. Say, here was the question we're given. If four atoms, or let's say four molecules of iron, that's ferrum, react with three molecules of oxygen to give us iron 3 oxide, this is called rustin. This process is called rustin. So now that's this equation, as you can see, there's a chemical equation here. Now, if 5.5 gram of the rust, which is iron 3 oxide, is formed, then what is the total mass of iron and oxygen that reacted? Now that's the first sub-question, another second question we're given. So let's say the second sub-question. If 22.34 gram of iron reacts with 9.6 gram of oxygen, then how much iron oxide is formed, provided the law of conservation of mass is being obeyed. Now, these questions are very interesting. Now let's see how we go about them. As you can see, the very first equation, the first thing we're going to ask ourselves is if this equation is balanced. If this equation is balanced, it means this really obeys the law of conservation of mass. As you can see here, altogether we have 4 atoms of iron, that's ferrum. Here also we have 4 atoms of iron. Right here we have 6 atoms of oxygen, and we have 6 atoms of oxygen also. 3 atoms here, basic atoms, with general 2 atoms here, that gives us 6. So this obeys the law of conservation of mass. But let's see how we can interpret this question. 5.5 gram of rust is being formed, of this is being formed. Then what is the total mass of iron and oxygen that is reacted? Now let's see, these are experimental figures. 5.5 gram of rust is experimental. I can say experimental figure. So we're going to get our assumed figure, our theoretical figure. Let's see what that looks like. So let's write this out. 4 Fe, then 3O2 gas, they give us 2 this, then solid. So quickly, iron has an atomic mass unit of 56, so that's going to be 4 times 56, then plus oxygen altogether 6 atoms, 6 times 16, oxygen is 16 up there. And that will give us, that will give us the iron also here 4, same thing, 4 times 56, and then plus oxygen 6 times 16. So what do we have? 4 times 56 will give us 224. Then this times this will give us 96. Atomic mass unit, or we can call that gram. The same thing, 224 plus 96. So what it means is that by the time this individual stuffs, iron and oxygen, 224 atomic mass unit, or let me say 224 gram plus 96 gram of oxygen combined together, we're going to have something. Let's see what we're going to get. So 224 plus 96 will give us, if you add this together, that will give us 320 gram. So what does it mean? It means that by the time 224 gram of iron combines with 96 gram of oxygen, we're going to get 320 gram of iron 3 oxide. That's the rust we're talking about. So this is a standard. Now you can see the proportion, the proportion of combination. Let me use that word. And that's what this law is all about. This law is all about the fact that the reactants, the stuffs coming together, combining together, they don't change in their constituent amount by the time they are done combining. They don't reduce and they don't increase. There's no creation and there's no destruction of these reactant substances. So they maintain their identity, they maintain their quantity. So let's quickly see. Now that means, what this thing simply means is that 224 gram of iron, when it combines with 96 gram of oxygen, will naturally give us 320 gram of the rust we are talking about, of iron 3 oxide, rust. So this is what it means. So we can also get the ratio of that combination. We can do it in different ways. Mathematical understanding is very needed here. So you can get the ratio. So if 224 gram of iron combines with 96 gram of oxygen, so let's see the ratio. That means 224 over 96. 8 could divide, the two of them. 8 and 22 is 2. 16, remember 6, 8 and 64 is 8. 8 here 12. 4 here 7. 4 here 3. It means they combine in the ratio of 7 to 3. So that means you have more of iron in this final rust, compared to oxygen. So 7 ratio, 3 iron to oxygen to give us 320 gram of iron 3 oxide. So you can use the knowledge of this simple ratio, to make our work very easy. So let's attend to the first question. So the first question now is, if 5.5 gram of rust has been formed, then what is the total mass of iron and oxygen being formed? Now don't forget that naturally, based on theoretical analysis. When you look at iron 3 oxide being formed, there is a ratio of 7 to 3 iron and oxygen in it. It's just a theoretical analysis. So if you now come to experimental analysis of this, if 5.5 gram of iron 3 oxide has been formed, then how much iron and how much oxygen, combine together to give birth to 5.5 gram of iron 3 oxide? Now let's see that it's very simple. Amount of iron now will be, let's use our ratio knowledge. So total ratio is 10, that will be 7 over 10 times 5.5 gram that is being formed. So you're going to do that. 7 times 5 is 35. Remember, 3, 7 times 5, 35, that's 38 gram over 10. But with the value, you're going to get 3.85 gram of iron, as simple as that. So the next you're going to do now is you're going to get the one for oxygen. Now, how to get the mass of oxygen that combined is simple. Since the total mass of iron 3 oxide form is 5.5, and the mass of iron form is 3.85. You can just say 5.5 minus 3.85. Or if you still want to solve our way to it, you can do that. The ratio proportion for oxygen is 3. That will be 3 over 10 times 5.5. 3 times 5 is 15, 5 keep your 1. 3 times 5, 15 plus 1, 16. 16.5 over 10. You divide by 10, you get 1.65 gram of oxygen. When you add 3.85 gram of oxygen, when you add it to 1.65 gram of oxygen, you're going to get 5.5 gram of rust that was formed. It's very simple. This law is a conserved law. As you can see, it's very easy. We easily use the ratio we got, ratio of combination, the ratio we got from our theoretical analysis to easily solve the experimental stuff given to us. As simple as that. So yeah, are the results. So for question B, now look at it. If 22.34 gram of iron reacts with 9.6 gram of oxygen, then how much iron 3 oxide is formed? Now this is very simple. We don't even need to go through the whole stress of of this. So since 22.34 gram of iron reacts with 9.6 gram of oxygen, then how much iron 3 oxide is being formed is very simple. Iron plus oxygen to give us iron 3 oxide like this. So now if 22.34 gram of this reacts with this, so what's it going to be then? It reacts with 9.6 gram, 9.6 gram of oxygen. How much of this are we going to get? Now it's very simple. Since the law states that the total mass here is going to be equal to the total product, you just have to sum them up. The sum of those two, that will be 22.34 plus 9.6. 0, this 4, this 9, 31.94. That's 31.94 gram of iron 3 oxide. That's the final answer. It's very simple. But if you want to use either of this, ratio stuff, you could still do that to get the same, the same result. So that's everything for this. So if you got these very questions right, it means you understood everything on the law of conservation of mass. So at this very point in time, we're drawing the curtain on today's lesson, and we're done with law of conservation of mass. So we're going to be watching out for the next law, which is law of constant proportion or definite proportion. So I'll see you in the next lesson. If you've enjoyed this lesson, subscribe to the very channel at EduMosaic. Share this lesson also with others, and follow me also on Facebook at Revolution Up. See you in the next lesson. Thanks.